This is October 2022 paper unit 5. Fission and fusion are the both nuclear processes. Which of the following statement is correct for both processes? So the nuclear reaction happen. It can be a fission reaction or it might be a fusion reaction. When we check the statement, no harmful radiation produced. No, the fission is having this harmful radiations. Nuclear binding energy increases when a reaction happens. When a binding energy per nucleon increase, the reaction is always exothermic. So B is the right answer. A very high temperature we need for fusion. We need a high, but fission we don't need that high. And the process can occur spontaneous, meaning not by itself. We have to make the condition feasible for this process to happen or occur. In question 2, the pressure law state that if a certain conditions are met, the pressure exerted by an ideal gas is proportional to temperature. Which of the following condition is not correct? Like this is which is not a valid condition. Absolute temperature must be used, like that absolute temperature, because if a temperature and pressure are directly proportional, we should use a temperature in Kelvin. Because if a temperature in Kelvin is double, then the pressure will also be double. The molecule in a gas must be identical for a same mass of a gas. It's about same mass of a gas, not about the particle should not be identical. Same mass of a it's valid for any kind of a gas. Even if we have a mixture of the gases like helium and neon, then it will also work. Number of molecules in a gas must be constant. Yes, that should be. Volume of a gas must stay same because we are applying P is equals to nRT. So the V should be constant. Number of moles should be constant. R is a constant. So T will be proportional to V. Radioactive source is placed in a few centimeters away from the detector. When a sheet of paper is placed, the detector, there is no change. So there is no alpha. When a lead of a thickness 0.5 centimeters is placed and the detector count reduces to background, what can be deduced from this? Because alpha cannot pass through paper, and when the paper was placed, there was no change. But beta can be stopped by aluminium, thick aluminium. The Hertzsprung and Russell diagram is there. So the labels are, remember, always, it's always like this label will be double, 12,000, and this will be half. So this will be 3,000. So X will be 12,000 and Y will be 3,000. That's a scale of the Hertzsprung Russell. The radioactive decay of a nucleus is described as a random process. Which of the following is a reason for this? The term random means like there is no order. We cannot predict what will the next radiation it will emit out. So there is a number of different decay paths. No, there are a number of different decay paths. Nucleus will probably decay after one half-life. Not correct. The nucleus will decay without any external stimulus. That is not about the random. That is called as spontaneous. This is a definition of spontaneous. There is a fixed probability of a nucleus decay in the next second. Like a fixed probability is there that the next nucleus will decay. The nucleus will decay in the next second. That's why we say it is a random process. The graph of a redshift against a distance in a meter was plotted, and the value of a gradient, the gradient of a graph, and which of the following expression gives the Hubble's constant? So the graph for a distance in meter of a redshift against a distance. So the redshift is actually the if we need the redshift, that's a change in a wavelength or change in frequency over original frequency. And there's also another formula that the redshift is equals to speed of the galaxy divided by the speed of the light. So if redshift multiplied by, because we need the Hubble's constant, okay? This is a redshift, and we know the formula V is equals to H naught D. So in place of V, I can write H naught. So Z is equals to H naught D divided by C. So the Z divided by C, Z multiplied by C divided by D will be equals to H naught. Where this is a gradient, the redshift and the D is the gradient is given. So if you multiply this by the speed of a light, like the gradient is this, Z over D is given. And if you multiply this by a speed of a light, we'll know the value for the Hubble's constant. So D will be the right answer. Then a space shuttle of a mass is returning to Earth of mass m. The space shuttle fall from a height r above the Earth, where r is equals to radius of Earth. Which of the following give the change in the gravitational potential energy? So if you want the expression, because the space shuttle of a mass r returning to Earth, the space shuttle falls from a height r above the Earth. So this is a Earth. So this is r here. The height is r, and this is also r. So it has returned to Earth. So we find the potential at point, as the gravity is not constant. So the formula for the potential at this point, this is given by a formula Gmm over R. So the potential at this point will be Gmm over R 2R, because the distance is twice. And when it reaches here, it will be Gmm over R. We need the change in the potential. So we just take a difference of these two. So Gmm over R minus Gmm over 2R. That will give us the difference in the potential. So it matches with option A. Sorry, option B for question 7. Um, and the formula, because it will match with option A. Why it will match with option A? Because the sign is a negative sign. Like here, the potential at this point minus GME. This is also minus GME. So when we subtract them, like when we put GMEM over R minus and minus GMEM over 2R. So when we simplify, this will become minus GM over R minus minus plus, it will become GM over 2R. So if I rearrange this structure, because positive is this one, so it will be GMM over 2R minus GMM over R. So that's why A will be the right answer. The potential energy at different points above, why we don't use the value of a G here, like we don't use mgh because the gravity is not constant. In question 8, a second pendulum has a period of a 2. Which of the following is a length? We have the formula T is equals to 2 pi under root L divided by G. This is 2 pi under root L over G, which is 9.81. 2 will cancel with 2. We'll take square both sides. So 1 is equals to pi square L over 9.81. And 9.81 divided by pi square will be equals to L. So 9.81 divided by pi square will be equals to length of this pendulum. Canopus and Ceres are two stars. Radiation from Ceres is 3 times the intensity of a radiation from Canopus. The distance of a Canopus is 36 times the distance of a Ceres from Earth. And luminosity is LC and the luminosity is LS. What is the ratio between? The luminosity means the power. So we have radiation intensity of a radiation on a flux. Flux is power on unit area. So it will be 4 pi d square. So this is a we are receiving the flux on Earth. So we can say 4 pi d square Fc into Lc, and that will be equals to 4 pi d square F L S Ls. If we divide the two equations, like left hand side will be divided with, so it will be 4 pi d square Fc into Lc divided by 4 pi d square Fs into Ls. 4 pi will cancel. The distance here for Canopus is 36 times the distance of a Ceres from Earth. So this is 36d square, like 36d whole square, and this is d square. Where flux, the radiation flux from a Ceres is 3 times the radiation flux for Canopus. So radiation flux is, this is 3 times the F. If this was F, this is 3F. We need the ratio between LC over LS. So F will cancel with F. D square will cancel with this 36. So this will be like 36 square. F cancel with F over 3. That will be the ratio between them. So 36 square over 3. So it matches with option C. A suspension system of a car is tested by a force, forcing the car into a vertical oscillation. The force frequency was gradually increased and a corresponding amplitude. There was a maximum amplitude A naught at a frequency F naught, which row shows how A naught change, A naught and F naught will change as a damping. So when a system is damped, both the amplitude and the resonant frequency will decrease. Like it will have a lower amplitude and it will also have a resonant frequency will also be. What we did, damping. Okay. Damping is reduced. If a damping is increased, then in this case, if a damping is reduced, both will have increase. So D will be the right answer. A will be the answer if it was increased. Like if the damping in the suspension system is increased, if you carry out more damping, amplitude and natural frequency decreases. But if we reduce the damping, the amplitude and the natural frequency will increase. So this is October 2022 unit